Hello, and welcome to Carbon, Chemicals, and Compliance with MillerKnoll, the second event of our three-part series, Demanding a World Without Toxics. My name is Luan Malake, and I'm Senior Researcher at the Healthy Materials Lab, and I lead the Dongia Healthier Materials Library. For those that are unfamiliar with our work, Healthy Materials Lab is a design-led research lab at Parsons School of Design at the New School. We are dedicated to placing people's health at the center of all design decisions. What that means in practice is that we raise awareness about toxics in our built environment and work to make healthier alternatives more accessible and popular. At HML, we understand that change begins when we ask questions and have conversations with experts from a variety of disciplines, which is why I'm very excited to introduce today's speakers. MillerKnoll, one of the largest and most influential design manufacturers in the world, has established ambitious goals for 2030. The path toward a more sustainable future is complex, and there are challenging obstacles, but MillerKnoll is committed to making bold changes. They understand the impact of manufacturing on communities, not only the end users of their products. Our speakers today will share with us the strategies, victories, and challenges they face on the road towards realizing their health and sustainability goals. Gabe Wing is Director of Sustainability at MillerKnoll Inc. and is responsible for leading the company's global sustainability efforts. Since he joined the company in 2001, Gabe has played an important role in developing the company's environmental policies and integrating sustainable design principles into the company's innovation processes. Gabe also works closely with key materials suppliers to support the development of sustainable products and leads CEU-accredited training sessions for architects, designers, and engineers. Gabe has 2 degrees in chemical engineering, and from 2002 to 2010, he was a member of the Materials and Resources Technical Advisory Group of the U.S. Green Building Council. Thank you for being with us, Gabe. Thaddeus Owen, who I'd like to introduce next, is the manager of Global Product Stewardship Team for MillerKnoll and previously served as Chief Sustainability Engineer for Herman Miller. Thaddeus has a deep love for the outdoors and studying nature, and after a decade spent developing pharmaceutical products, he couldn't face another day adding terrible ingredients to children's medicine. He shifted gears and engineered a successful transition into what he does now, keeping toxic chemicals out of products we all use every day. Thaddeus holds a personal training certification, nutrition certification, master's degree in holistic nutrition, and a BS in chemical engineering. He also teaches others how to upgrade their biology through the online platform Primal Hacker. You can find out more about both of them on our website. And before I let you speak, I just want to make a few housekeeping notes before we start. The Q&A is open, so while Gabe and Thaddeus are speaking, feel free to jot your questions down in the question box. Or if you see a question that someone else has asked that you like, give it a thumbs up to push it up to the top of the queue. Please use the Q&A for questions and not the chat box. Questions that are in the chat box will not be added to the queue. Also note that this event qualifies for 1 AIA CEU HSW credit. At the end of the event, we will share a link in the chat for you to register for your certificate. And now, let's let our wonderful speakers speak. Thank you both for being here.
Hey, good afternoon, everyone. And thank you for that introduction, Luan. Thaddeus and I are both excited to be here with you today. Just sharing some of the insights that we've learned during our time at MillerKnoll regarding those 3 topics of chemistry, carbon, and compliance. What I think where I'd want to start and help set the context for the discussion we hope to have today, it's really around how we think about design across MillerKnoll as a way for us to solve problems, but hopefully at the best we can use design as a way to harness the unique talents of our company and our employees to make a positive impact on the planet. And if you're not familiar with MillerKnoll, we thought we'd share some images to give you some insight into the types of products that we manufacture and the spaces that we cover. We go to the next slide, Thaddeus. Here's this collective of brands that make up MillerKnoll. and what I characterize us as leaders in the area of modern design, who again use design as a way to solve problems that are facing humanity. And many times the problems that we solve happen to be related to furniture, but that's not necessarily all the problems that we solve. As we jump into the conversation today, I thought I'd set the stage with walking through a very high level overview of our 2030 sustainability strategy and some of the goals and aspirations we have, and the problems that we want to address specifically from a sustainability perspective. And the first one is directly related to climate change. And so we made the commitment, the promise to reduce our carbon footprint from our products as well as our operations, with the goal of cutting those in half by 2030. And for us, as you'll see as we go through the discussion, our suppliers play a huge role in our carbon footprint. And so we would be remiss if we weren't bringing our suppliers along on the journey as well. And we go to the next slide. When we think about the circular economy and the notion of designing out waste, I think that's the second area of focus for our business. And we've built goals around the elimination of landfill and reducing the amount of water that we use to produce our products. We've also made a commitment to eliminate single-use plastics across our organization, primarily around our packaging. And if anyone here has ever been involved with receiving an order of 1,000+ workstations, you'll recognize that there is a mountain of packaging that comes with furniture today to make sure that our products arrive undamaged. And we're doing our part to make sure that those materials are recyclable and working to eliminate single-use plastics. And our last area of focus from a sustainability perspective is to make sure that the materials that we're sourcing are safe and sustainable. And when we talk about safe, we've got a huge focus on the chemical content. And then to make sure the chemicals are safe for people in the environment, we're also working to become increasingly circular. And so we've got the ambition that at least half of the materials that we're sourcing across our collective of brands are using at least 50% recycled content. And for materials that are grown, not extracted, so materials like wood, cotton, wool, those materials we need to make sure those materials are sourced ethically as well as sustainably. So if I dig a little bit deeper into the product carbon footprint of our organization, I thought it would be helpful to provide all of you in the audience today with some context around where does the carbon come from for what I would say a typical product manufacturing company whose products don't consume energy. So for us on the furniture side, and looking at this graph to give you a relative order of magnitude, we've over on the left-hand side of the graph, you would see what we call our scope 1 or scope 2 emissions. Think of those as the energy that we use to power our factories. And so we're looking at the natural gas and the electricity that goes into our factories. The next line, the green line, represents our ability to source renewable energy at 2 of our largest manufacturing sites. So we've been able to source hydro and wind power at 2 of our factories, which effectively reduce the scope 2 or the electrical emission slide. So we've been able to take a chunk of carbon out of there. Our hope is that at some point in time, right, those lines come down to 0 as we work to decarbonize our operations. We're also tracking how much energy it takes to deliver our products to our customers. Fairly sizable. And having our employees commute to work, whether it's mostly by car in the US, but if we're taking public transit, we've got a guesstimate for that number. We track our business travel as well, which is a relatively small slice. And then I really think if you look at that last graph, that last bar, our product carbon footprint, much larger than the carbon emissions that come from our factory and all the other sources. So from an opportunity standpoint, we realize that the biggest lever that we have to pull as an organization is making sure that we understand what's driving the carbon footprint for our products, and then working with our design teams to make sure that we're taking bites out of that large bar on the right-hand side of the slide.
So I'll jump in. One of the things that surprised me when we started this work, so it was back in 2006 and 7, we started understanding our product carbon footprint. And you'll notice that product delivery is on there, but product and part distribution, shipping parts around the globe, getting parts shipped to us, that's not a category in here. And we do track it, but surprisingly, I was always like, let's say this company in the US raises chickens and they ship the chickens to China, they get processed in China, packaged, they get shipped back here for distribution. That seems like a huge carbon footprint. And in fact, the carbon footprint of transporting things globally is minuscule compared to everything else. So I know people are always like interested in carbon footprint and what contributes to it. And oddly, global transport does not contribute very much to the carbon footprint of a product. The two things that contribute most in terms of our products, as Gabe said, are the materials we choose. And if it was a powered product, think about like a laptop or a washing machine, the use phase of the electricity is going to contribute most, along with the materials, to those carbon footprints. So I think those were surprising things to me that I hadn't thought of before we did this work.
Yeah, Thaddeus, I think that question seems to come up every time we walk through this. That a couple observations that I'd share is that our ops team, before we pulled this data together, they were 100% sure that they were the largest source of carbon for us, and it turned out it's actually our product team. And so when we look at that transport slide, I want to put a couple caveats on your comments and saying, when we ship products around the globe on ocean-going freighters, it's very, very efficient, right? So when you have an ocean full of containers that are packed, the slice of carbon that each item on that ocean freighter, that we allocate to each item on that freighter, is pretty small. So it is very efficient, even though there's a large carbon impact from all the boats going back and forth. When we start shipping products around the globe using air, because we're in a rush, that's a game changer. Carbon footprint goes up dramatically. And so if we unpack that product carbon footprint, the transport is small. I want to say about half of that footprint is directly related to the material choices we make. So material selection is something that we absolutely have to focus on from a design standpoint. So there's a takeaway from this slide. As people in the audience are or become product designers, material choice absolutely matters, and it's something we've got to be very knowledgeable and spend a lot of time thinking about, that we're making the correct decisions for the product we're designing.
Okay. As we talk through like what MillerKnoll does as a company and how we look at sustainability in our products, one of the major things that helped steer our decisions over the years were really two things. Our relationship with Bill McDonough and Cradle to Cradle, which a lot of you are familiar with, and he was a very visionary, sustainable architect and designer. And we had relationships with him going way back into the early 90s. In fact, our manufacturing facility for our task seating was designed by Bill McDonough as a LEED building before there was LEED. It was kind of the concept to create LEED. So it's like a LEED innovative building before the standard existed. In addition, this slide here really shows the 6 classes of chemicals that Green Science Policy Institute is interested in. And that's been led by Arlene Bloom over the years. And we've had a close working relationship. They hold retreats out in Santa Cruz every year. We've been to a number of those. And they partner with other nonprofits, academia, as well as industry. So when I was there at a retreat, it was like Facebook, Google, Kaiser Permanente, Harvard, like all these big players in this world of how do we design and ask for more sustainable products in our world. So these chemicals are being grouped into broad categories by Green Science Policy Institute. And what you're seeing now in the legislative law is that these groups are starting to be regulated as a whole rather than individual chemicals from them, which has always been the standpoint of Green Science Policy Institute. And through our working relationship with Cradle to Cradle and the 6 classes of toxic chemicals group, we have created our own internal banned list of chemicals that basically exactly follows this list in addition to some other chemicals. What we do internally is try to eliminate the use of potentially dangerous chemicals before they're regulated. So if they're regulated, obviously they're not going to be found in our products. But if these chemicals could cause problems, but the science isn't really there yet, and there's enough concern from our customers and us internally, we'll add them to our internal list of banned chemicals that we proactively require they get removed from or don't appear in our products whenever possible throughout all the life cycle. One of those classes that we worked with really early on were flame retardants. So if you remember back, in the 90s and early 2000s, the state of California, which is about a third of our national economy. So it's a huge volume of sales from all businesses that are sent into the California market. California required a certain flammability regulation that in essence forced us to add flame retardants to our products. And that wasn't just us, it was every person that manufactured a sofa, chairs, any kind of a stuffed article that you would sit on in your home had to have these flame retardants in it to meet the California law. And we were finding more and more information through our work with Cradle to Cradle and others that we didn't want to be adding these flame retardants. So eventually California was able to slightly modify their law so that you didn't have to have a flame retardant in it. And that law is still the case where you can add a flame retardant or not in both the US and California. But we proactively removed the flame retardants from our products prior to any regulations that banned flame retardants. If you're aware, there's 6 or 9 states in the US that have now banned flame retardants in upholstered furniture. And this really hit home to me because throughout all the history of the 2000s, there's been types of flame retardants that have been illegal to manufacture and utilize in the US for certain reasons of either health or environmental concerns. And at Herman Miller, we obviously very proactively through our relationship with Cradle to Cradle had removed those flame retardants quite early. But in my own sofa at home, there was this program with Duke University where, and I don't know if it's still going on or not, but you could take a small piece of foam, like a little cut piece of foam out of your sofa at home and wrap it in tinfoil and send it to Duke University. And for free, they would analyze it for flame retardants. And they would tell you the type of flame retardant, the actual chemical being used, and the quantity being used. And now my sofa at home was from like Art Van sofa or something, not a Herman Miller piece of furniture. I didn't know if it had flame retardants or not. Back in those days, there weren't labels on your product to tell you whether it had flame retardants, which today there are. And when I got the results back, they told me I had 6 pounds of a banned flame retardant in my sofa at home. And I was like, oh my gosh, like, well, what do I do with this? Like the flame retardants come out in the dust. I don't know that I should be sitting on it. I've got 2 new babies that I don't want like playing around on my furniture. And if I give it away to somebody or sell it, now they're going to be exposed. And so like those issues of like, what do you do with some of these products when they have banned, this was a banned flame retardant in the United States, really hit home for me in the work that we do of like, how can we be more proactive with these classes of chemicals in keeping them out of our products in the first place so we don't end up with these things that at the end of their life or even in the middle of their life, we don't know how to deal with them.
Yeah, Thaddeus, I think to me, the whole learning curve that we went through on this particular class of chemicals, right? It doesn't, we're focusing on flame retardants, but it could be any one of those 6 classes. It's understanding the need and why these ingredients are added to our products. And I think for the flame retardants, if we think about how they're used inside furniture, I could wrap my brain around that, hey, if I've got an electrical component, fire safety is kind of a premium if I'm powered and I want to make sure that don't have the ability to start a fire. And to me, the problem is that we've got to come up with other solutions that allow the product to be fire safe. But then when we look at unpowered pieces of furniture or things like children's pajamas, like there's absolutely no need for products like that to be loaded up with flame retardants other than there's been a push And people manufacturing, I'm using air quotes, manufacturing stories or reasons why it makes sense to do that. And I think for us as product manufacturers, for us as consumers, when we're aware of these issues, we work to change California and have them end up in the right spot. There was public pressure, there was pressure from manufacturers. And I think as I look at those other classes of chemicals, right, I think we need to do the same thing. We need to move government and industry and consumers to the right spot. And I think it all starts with education.
Great. Thanks, Gabe. Now, the title of the slide kind of tells you something here. We have not added flame retardants back to our products in the United States. However, just like California, the laws in the United Kingdom require the addition of flame retardants into upholstered furniture. So now we're in this quandary where we removed all the flame retardants from our products, and we're becoming a more global company, as most companies are, and we're selling into the European market, into the UK specifically, and they're telling us that in order to meet their flammability test, we have to have flame retardants in our product. So this is one of those areas where, because of the way the regulations are written, we must by law meet them by adding these flame retardants into our products. So now we have to have two separate product lines, one for the US and one that goes into the UK, because we keep flame retardants out of all of our products pretty much globally, but now we have to add them back for this one market in the UK. So again, as Gabe mentioned, we are working with regulators in the UK and with the industry associations that write the standards to try to, what we're calling, correct this issue where we can still create safe furniture without the flame retardants. So like if, for example, your sofa did burn, that it's plenty safe enough for you to, get out of the house or whatever you need to do without adding these toxic chemicals that are being added into the dust. And of course, the other thing that we talked about is when we have to add a flame retardant, we are very careful about the flame retardants that we allow in our products to ensure that the safest version of any flame retardant we can use is what's being used in those components.
So I'm going to change topics and talk a little bit about the global issue of waste plastics reaching our oceans. And so this is an all too common image of what a beach can look like in an area where we don't have adequate waste collection. And so that plastic all sitting there is what we'd consider like ocean-bound plastic. It's not quite in the ocean, but you can imagine that, boy, it's going to end up there, which creates all sorts of problems. So if we go to the next slide. That plastic, when it reaches the oceans, it doesn't biodegrade. It breaks up into tiny little pieces, and those pieces stay inside the ocean. And we were talking about chemistry, and those pieces of plastic are great sponges for all the toxic chemicals. Those 6 classes of chemicals that we disperse in the environment all concentrate inside those tiny pieces of plastic, which then get eaten by little fish and big fish and ultimately us. And so not only are we just distributing those plastic pieces in the environment, they're loaded with those 6 classes of toxic chemicals or hazardous chemicals. So the problem, to put it in context, today there's 86 million tons of waste plastic inside the oceans. We're adding 8 million tons every year. And every minute, that's like dumping a large city-sized dump truck into the ocean. And if we don't change the way that we operate, there will be more plastic than fish in the ocean by, it used to be 2050. That year keeps coming forward. So we were actually approached by one of our customers, Dell. We were helping Dell restack their corporate headquarters in Austin. And as they got to become more familiar with our brand, they were connected to a nonprofit called NextWave, and they were working with NextWave to figure out how do we solve this ocean plastic issue. And they were looking for partners to work with them to start figuring out how do we design or redesign our products where we can take those waste plastics and then bring them back to life as the products that we all manufacture as brands, as product manufacturers. And we also needed to stand up supply chains in parts of the world where collection infrastructure didn't exist. And so if we wanted to work at speed and scale, Dell and NextWave realized they had to have some partners. So we're super proud to be one of the founding members of NextWave, and the collection of brands. I've got just a few of them up on this slide, but the first image is from Trek Bicycle, and that's their water bottle. They call it the Bat Cage, made out of fishing nets. We've got carpet from Interface. You see our Aeron chair. There's some packaging products from Dell, and HP has been doing a phenomenal job with inkjet cartridges using recycled polyester bottles from Haiti. And to me, the exciting thing about this group is that we're actually working together, and we don't get together and just talk, but we're actually doing things, and we've got a shared set of goals to solve this global issue that has allowed us, as one of the smaller companies, to work at a scale that we couldn't do alone to address this global issue. So for us, we're getting started in these numbers. While they're relatively small in the grand scheme of things, I think it was really important for us to show people inside our company and outside our company that it is possible to redesign products to use these ocean-bound plastics in premium goods. And so to date, we're pacing at using about 234 metric tons of ocean-bound plastic in our product offering, including the textiles, some of the small plastic components that you see on that white shelf. And then the Aeron chair for my team, for our group, when we said, hey, what product do we want to go after? Given the iconic nature of Aeron and the overall impact to our business, we said, hey, if we can do it in Aeron, we can do it in anything. And so to date, we've been able to divert roughly 23 million water bottles and keep them out of the ocean. And so going back to our goals, we turned off the tap on our use of single-use plastics. And then we're working together with all of those brands to grab those waste plastics and then bring them back to life in products like the Aeron chair. So you go to the next slide. I think it sounds easy, right? I just walked through in 30 seconds, like, oh, we got the ocean-bound plastic, we joined this group, and we launched product. It's not that easy. Using recycled plastics, it's a huge challenge. And probably the first most obvious one is if you look at those ground up plastic pieces there, they're multicolored. And if you remember as a kid, if you mix all the paints together, what color do you get? You get brown or black. And you can get recycled plastic in any color you want, as long as it's dark gray or black today. And so there's some big challenges with the color limitations of those recycled materials. The other thing that I would offer is, if we think about how our processes are all designed to use virgin materials, we want to make the same product and the same component time after time. And we've got an Aeron chair coming off the end of our factory line, something like every 14 seconds, another chair is coming off the end of our production line. We want to take all the variation out of the manufacturing processes at MillerKnoll, at our suppliers. And when we throw in these recycled ocean-bound materials, the variation gets much bigger. And so designing around that variation is something you have to think about. When you push the boundaries of design like we do from a performance perspective, and Studio 7.5, one of our design partners, one of their mantras is not a molecule more than needed to make a product. So we're hyper efficient with our material design. And if you start adding more variation with recycled plastic, you need a little bit more molecules. So those are the things that you have to think about when you're working with a material that's recycled versus a virgin material.
And I think one other point from a compliance standpoint, since I'm the compliance guy, is all these chemicals that are being regulated out of plastics for a reason, they end up in these recycled content materials. So in some cases, as a company, we have to make sure we test for those so they don't end up back in our products. And in other cases, we have to think about, as basically humanity, how we deal with those chemicals that are already in the recycled supply chain. Do we throw them in the landfill like these chips of plastic, where they're going to release their burden into the environment? Or do we reuse them in products where they'll be in a durable good and locked up for many years without exposing the earth or people? And so I think that's something that, as we, both MillerKnoll, but also as humanity begins to farm, the landfills and the old materials for new goods or repurposed goods, we really have to sit down and think about how to deal with this legacy chemistry of things that were used in the past that we don't want around today, and how do we deal with that? So that's always an issue that we have to think about as we use recycled content. And is it better to lock it up in a product and make sure there's nothing that's exposing anybody or the environment? Is it better to let it go into the landfill and refuse to use recycled materials that contain some of these legacy issues? And then how do we deal with them if we choose not to use them? So I think those are questions that I haven't personally answered, and I think we need to answer as a group rather than one individual company.
Yeah, I think you're also bringing up the point, like, hey, when we're designing these products, thinking about what happens at the end of life is critically important. And if there's something to be optimistic about, it's the fact that recycling is taking off. We've been in this, you and I have lived in this space for almost 20 years. And it's becoming increasingly difficult to source recycled content. If you look at the move that Coca-Cola recently made, and they're buying up all of the recycled PET, which is great. Like they're doing their part to close the loop on that particular material, which makes it hard for somebody like MillerKnoll to get access to that material. So a year ago, you could get all the recycled PET you want. Today, it's much harder to find that material, which to me says we're heading the right direction. And then I think it's also interesting to note, and you brought this up in the notes, Thaddeus, like some of the signals that we're seeing where Sprite changed the color of their bottle. So we talked about the color limitations. And if you're a Sprite drinker, you know that Sprite has been in green bottles forever. And I don't know that Coca-Cola has talked about it, but the fact that they moved to a clear bottle, that colored mess on the left-hand side of the screen, if we had clear plastics, we can make any color we wanted out of it when we iterate through that and grind it up and recycle. So starting to think about that from a design perspective, what happens to my product when it's no longer needed, and what changes could I make in order to facilitate recycling? Those are the things, that's the conversation we have with our design teams.
So that brought up a point. If you are a designer and you want recycled content air-on chair, but you want it in purple or green or blue, often because the recycled content materials come out gray or black, to get the color you want, the aesthetic that you want, we need to add a ton more virgin material and colorant to make those colors. So you'll notice that we use recycled content in a lot of areas where the colors are gray, black, or brown. As Gabe mentioned, that's an easy color to make, and it doesn't add virgin material at high quantities that other colors would. So as a design community, thinking about the aesthetic you want and the materials, you have to decide sometimes, like, your aesthetic might have to shift in order to get the recycled content you want. And that design intent has to be decided up front. Okay, this, you can kind of read this little cartoon on your own as I'm talking through here, but one of the things, like with flame retardants, that we find in the real world when we talk about even compliance to these environmental laws, there are conflicting laws in the world. So if you think about what just happened in California, they passed a law that requires you not say a product is recyclable if it's not currently being recycled at a rate of 60% in the state of California. Totally makes sense that you don't want to do any greenwashing, and we don't want to say something's recyclable if the consumer can't actually bring it to a recycling facility. And what's happening is in Europe, they have the opposite law, where they require the product be marked as what type of plastic it is with the chasing arrow symbol, the little triangle with the chasing arrows, to ensure, especially for a durable good like our products, that in 10 or 20 or 30 years from now, when you go to dispose of the product, you can identify the material it was made from and what recycling stream it needs to go into. So California is saying you can't do that because today the recycling facilities don't exist for every plastic type. For a durable good, that might be short-sighted, that our goods are not being thrown away tomorrow. They're being disposed of oftentimes, like my Aeron chair I've had for 15 years, and it's still in absolutely perfect condition. And it's going to go on to someone else after me. So it could be 40 years or longer before you get rid of these products. And knowing how to recycle them efficiently after that time period, I think is critical and short-sighted if you tell people that you cannot add a recycling symbol or logo to those to identify the plastic type. So I think there's some laws that are in conflict here, and we're kind of being told two different things. And the global regulators are not either working together or looking across to see what everyone else is doing. That creates a challenge for us. And finally, around innovation, I know that through Parsons New School, you've been looking into like mushroom and mycelium technology. And personally, I love that. I think it is definitely a movement that's going to have a lot of progress in the future. And it can be used for so many things, from cleaning up toxins to building products. We have looked into using mushrooms mostly in the form of work surfaces. And there's a pretty innovative company. They're originally out of New York. I think they're in Indianapolis now. And they presented to us these mycelium boards to use as work surfaces. And they look beautiful. They're obviously, the sustainable material that becomes, a product, becomes waste, becomes food, becomes a new product. And it's a great story. What happens in that innovative space so far is every board we've tried to use failed after a short amount of time in terms of warping and bending, or in terms of taking on moisture and then flaking or swelling. And that's one of the things you run into with innovation is like, we would love to use more of these materials, and we need more innovation occurring both within the global industry so that we can take advantage of those materials, and within the design world of people coming up with these unique ideas, and then working with the engineers so we can ensure that those innovations actually work in the real world long enough for them to be a viable solution. So I love the concept of using mushrooms. I think there's tons of uses already in the built and durable good environment. I think it's been a lot more challenging for us, although I'd love to see some mushroom work surfaces or wall panels or things like that, because it's just such a cool story.
I think that Thaddeus, the mushrooms are a great example of the innovation that we have to have if we're going to achieve our carbon goals. And I think more broadly, we need to reimagine the way that we design and manufacture products, because our current system, it doesn't work. And so for us, like, sustainability and innovation at MillerKnoll are linked. And whether it's mushrooms or low carbon plastics or bio-based plastics, those are the types of innovations that we're looking at as a way for us to decarbonize our business and make sure that we're doing our collective part to lower our footprint as we aspire to get back to where I started. Is like, how do we use our business to create a positive impact? So if we were growing mushrooms in a sustainable way, through a sustainable farm that we're restoring the ecosystem they're in, like, that's where we need to be versus this linear take, make, waste model that we're all stuck in today.
Great. So we appreciate your attention today, and we're looking forward to some questions.
Thank you both so much. Here I am. Thank you both so much for that. It was so interesting. And yes, we're going to open the floor for questions. And just a reminder to the audience, you can upvote the question that you want to hear, and we will be, I will be reading the questions in the order of the upvotes. But first, I want to start with my own question. I was wondering, you've talked about recycled content, and it's all really interesting, and things are changing rapidly. And I was just wondering, like, if you could talk a bit about what the future of recycling is like as you see it, and what the next steps are in recycling, and sort of ensuring a sort of streamlined process for it.
Yeah, I could maybe take a stab in Thaddeus if you want to add on, but what I've seen is like, I think the mechanical, what I'll call mechanical recycling, where we sort of grind up existing plastics, mix them together, and then repelletize them and shoot them again. I think that's becoming more robust. I'm also seeing what I'll call chemical recycling methodologies take place, where we have the ability to, what I'll call like depolymerize materials. So if you think of a polymer as a long piece of spaghetti, every time I mechanically recycle it, that piece of spaghetti gets shorter and shorter and shorter. And at some point in time, like I don't have the physical properties that I need to actually be a structural material. With chemical recycling, we have the ability to unzip that molecule. And so I end up with like new properties with the ability to color it. And what I'm seeing is the large petrochemical companies are starting to make investments where they're actually recycling materials. So to me, that aspect is getting real. And then you bolt on the natural-based materials and our ability to use bio-based plastics, whether it's mushrooms or things like PLA. All of those things are coming. So I don't think it's an either or. I think it's a both and.
Mm-hmm. And that process that you're mentioning is like it's recycling chemicals rather than recycling plastic in a way.
It's actually taking the plastics and then using chemistry to unzip the polymer and make it like new, if that makes sense.
Wow. Okay. That's super interesting. So let's start with our first audience question. Can you speak to your experience or thoughts with take-back programs for the repair and manufacturing of your products for resale? Is there something like that in the works for Herman Miller?
That's okay. I'm still, after 20 plus years of saying Herman Miller, still comes out of my mouth sometimes too. So MillerKnoll, actually both of our organizations in the same year in 2010 launched take-back programs. I'll tell you, they're imperfect. They're an imperfect solution today, but our corporate branded program is called Repurpose. And what I would describe it as, think of it as like it's primarily a Match.com service at its best, where we match local nonprofits in municipalities across North America. So if you're a nonprofit and you need furniture, and we're aware of a large to small opportunity where we've got what I'll call a contract customer, a corporate customer who bought some furniture, we will take their no longer needed furniture and put the hands of local nonprofits in the area. We'll also help them resell what products they can. And then what we can't donate or resell, we'll recycle. And that recycling process involves largely sending those products through an automotive shredder and recovering the metals and sometimes some of the plastic.
Okay, great. Next question. If you have removed all of the 6 chemical classes from your products, or have you removed those 6 chemical products, then have you also pursued the declare label?
You want to take that with Thaddeus?
Well, sure. So the 6 chemical classes that are referenced are included. So, we worked with the Green Science Policy Institute, as I mentioned, in Cradle to Cradle, and we created our own banned list. And there are some cases where we cannot avoid use of some of those chemicals, and those have to be done on an approval basis by the 2 teams, product stewardship and sustainability. So there's like some areas where, like for electrical products, you have to have a flame retardant by law. For the UK, you have to have a flame retardant in the furniture by law. So there are areas by code or by law where we have to conform by using some of those chemicals. And like I said, we look for the least potentially harmful chemical that we can find, or a non-toxic chemical. In some cases, there are non-toxic versions of those chemicals, even though the whole class as a whole is internally on our banned list, but also regulated. So we are actively removing them all the time when we can, or using the least toxic or completely non-toxic versions where you can eat some of these things and they're totally fine, like boron as a nutrient, can be used as a flame retardant, doesn't always work. So we continue to remove them from our supply chain. There's some newer classes that have been added, like PFAS, and I saw some questions around PFAS as well. And those, because they're so new and because they can be used at such a low quantity, and in the past, they've never been regulated. And often our supply chain doesn't know where some of these chemicals reside. We spend a lot of time educating suppliers on how to go and find these chemicals so they can alert us of their presence, and then we can remove them or work through solutions. So I would say I feel very comfortable that, you know, we're ahead of the game almost across the board with how we're looking at these chemicals in our products. We're very knowledgeable, almost to the point of like, you know, we're like the nerdy chemical engineers, Gabe and I. I'm like, we can tell you the exact chemicals that appear in a lot of our products in depth. And there's thousands of individual chemicals that can appear in our products. Like every product is made up of many chemicals. Lots of chemicals are healthy. Some chemicals are not so healthy, but everything contains chemicals. And we can tell you pretty much what all of those are in the majority of our products. So I would say our knowledge is very deep, and we continue to learn and work through our supply chain to help educate them to get us the best data. We're not manufacturers of like plastic or powder coat or electrical products. Like we buy purchase complete components to build them into our furniture. So we really rely on our supply chain to help us navigate some of these issues.
Okay. And have you pursued the declare label?
Oh yeah, I'll leave that to Gabe.
So we have declare labels on some of our products. I think our preferred approach is think of it as an ingredient disclosure. Right? So if you bought a packaged food item, you get a list of ingredients. We publish what we call material ingredient disclosures. So if you're interested in those, the best source of information for MillerKnoll products, if you want to see what information is available, there's a website called Ecomedes. And if you go to Herman Miller Ecomedes, if you Google those two terms, you can see how transparent we are with all of the information related to MillerKnoll products.
Great, thank you both. And can you address how MillerKnoll is eliminating PFAS chemicals, and also your views on the life cycle assessment impacts of polyurethane foam?
So polyurethane foam has some unique life cycle impacts. So someone is probably very aware of life cycle impacts and how they work. Life cycle impacts, when you do a life cycle assessment and LCA, you're looking at like typically the time you mine materials or extract materials from the ground. If it's a petroleum-based product, you're cracking the petroleum and taking off different fractions and then making a plastic granulate or a polyol, and then an isocyanate in terms of polyurethane, and bringing them together to make a polymer called polyurethane. And when you make plastics and metals, the typical life cycle impacts are buried in the energy used to produce those products. So like you can look at some plastics, they use a lot more energy, so they have a much higher carbon footprint, and they have much higher impacts around like acidification, because you're using more power from a power plant to make that plastic type. When it comes to polyurethane, it actually has a larger carbon footprint in the what's called eutrophication area of life cycle assessment. And eutrophication is like where water supplies get added nitrogen, which is a food for plants. And then you can get these algae blooms. And when you get an algae bloom, it starves the oxygen from the water, which makes it harder for fish to get oxygen that's dissolved in the water. And so that's a unique attribute of polyurethane, that rather than it contributing more to global warming and acidification, it contributes to this eutrophication category. Now, in terms of like runoff of fertilizers and other things from industrial agriculture, it's minimal. But in terms of materials we use, it is the largest contributor to eutrophication of the materials we use. Just like things like virgin aluminum might be a large carbon footprint actor versus recycled aluminum. So, we address that by looking at alternative materials all the time. As Gabe mentioned, when we design products, material selection is key, and how we choose that selected material. We like to look at the energy use of the raw material and the eutrophication if we're using like a polyurethane type material. And polyurethanes, we've gone back and forth all the time of like, do we use latex? And then so many people have latex allergies and they want to make sure there's no latex in the product. And there's a lot of nuances with like, how do you do comfortable ergonomic soft seating without foam? And that's largely like what the Aeron chair invented, is not using foam for the chair, but using a suspension textile to create the comfortability of the chair. So I think we pioneered quite a bit in that area with a lot of our high-end task seating, in terms of getting away from the impact of like a polyurethane by minimizing the use of it to, in some cases, not using it in the seat or back of a chair at all. And then elimination of PFAS. PFAS is the hot topic, right? I was the chairman of the city commission for environmental for my city, and we have a 3M plant in our city. So 3M and DuPont and Dow, like they created some of this chemistry, and it went into a lot of products because people asked for it. And certainly in the furniture industry, like people wanted stain and nonstick textiles, and that's where you'll see the majority of like a PFAS use in the furniture industry is on these high performance textiles where people wanted a specific benefit. Same with carpets and rugs. And so people say, I want stain and nonstick, and the only way to get that at the time, and even till today, was using a PFAS chemistry that up until very recently was not regulated. And what I mentioned is like, it's been on our banned list and in our work with the 6 classes of toxic chemicals for a long time. So we're pretty advanced at identifying where that could be in our products and working with our supply chain up front to eliminate or find alternatives to that. And I think we've been very successful. And I would say like the hardest area that I think even for consumers is going to be like in rain jackets, like Gore-Tex rain jackets. And then the same thing would be for outdoor textiles. You want your outdoor sofa that you've got in your garden or whatever that has upholstered cushions to be water repellent, so you're not absorbing water and mold into those cushions. And I think as consumers ourselves, we're going to find that products that can do what PFAS did don't exist. And as we eliminate them from our products completely, we can't offer the same benefits in the past as those chemicals provided. So I would say, like, we're definitely addressing the issue very quickly. We have a lot of experience doing this. And when I look at the industry, I think the automobile, the aviation, the high-tech gear, like tents, camping equipment, Gore-Tex, outdoor furniture, like that's more of the area I think is going to be a big concern to all of us. So like, how come my stuff doesn't work the same way? And are there going to be innovators that can step up to solve those problems with non-toxic chemistry?
Yeah. If I throw in one more, just build on the end. And I think as we look at those alternatives, it's incumbent on all of us to make sure that we're not making the regrettable substitution where we find out that like, hey, we've got this better substitute for PFAS, and we don't do adequate investigation and find out that whatever the alternative is worse than what we were using before. And we've already seen that with some of the purported alternatives to BPA, chemicals like that. So again, just to me, it's a constant reminder that even as we move away from these class of chemicals that are problematic, we need to make sure what we're looking at as the alternative is truly better.
Great, thank you. That was a really great answer. Another question, how do you mitigate the harmful chemicals that are in the recycled plastics? I think that's a really good question, because as a lot of people know, when you recycle plastics, there can be a lot of toxics that remain or become more enhanced.
So number one, right now, we avoid the use of those chemistries. So we run screening tests on the recycled batches of materials to make sure that we don't have things like phthalates, BPA, heavy metals. So right now we're screening to ensure that we don't put them into our products. But the argument that I posed originally was like, well, then who does get to deal with that? And is it going to be sent to the landfill, or is someone else going to put it into their product? So I think that there's an argument for, is there a way to lock up that chemistry that's already been created? It's already in a product, and now it's in the recycling stream. Is there a way to lock that up and continue to use it as a durable good so that it can't expose people or the environment? I don't know the answer to that. I know in some cases it's possible with certain types of materials, like a PFAS chemistry. You could lock it up inside a polymer to where it can't migrate out. And unless you're chipping and dusting the polymer and spreading it over the land, it's going to stay right where it is up until you send it to a landfill and let it degrade over however long plastic takes to degrade. So I think this is one of those discussions we need to have. I don't know, Gabe, where you're at, but I don't know that there's a great answer other than we've been avoiding the use.
Yeah, I think first is making sure that you work really closely with the recycler and understand what materials are coming from, what their streams are, so that you've got a well-defined recycling stream identified. Testing is paramount. You've got to do that. And then again, I'll point back to innovation. I think some of the advanced chemical recycling technologies that we're looking at, where I can pull out the polymer I want and get rid of the rest of the junk. Like, I think those are the things that are going to allow us to make sure that we're capturing the valuable polymers that we want and finding a way to pull out the things that we don't want, like flame retardants and PFAS and those other chemicals. We're not there yet, by the way. Like, that's definitely in the future. But my crystal ball says we're going to be smart enough to figure out how to do that piece.
Okay, great. So we're actually like just about to run out of time. But this was like really fascinating conversation. Yeah, it's just interesting to hear all of the things that you have to weigh when you're a big company like you are, and trying to do as much as possible to do the right thing in terms of health and sustainability. And I just really appreciate you guys talking through your process and the things that you've learned with us. And I'd also like to thank everyone for attending, and thank you to Gabe and Thaddeus for being so generous with your time and expertise. And thank you to the Friends of Healthy Materials for your generous support, which makes these events possible. We want to remind you that we still have one more event in our fall series, Demanding a World Without Toxics. Please RSVP for Design Equity Isn't a Trend, It's Our Foundation, with Kia Witherspoon on November 9th. Kia Witherspoon, interior designer and founder of Determined by Design, believes that well-designed interior spaces should be a standard for all. She will discuss how to build beautiful, healthy, affordable housing that acknowledges a community's history, culture, and diversity. The registration link is in the chat. The link for the sign up to claim your CEU is also in the chat. Thank you all for coming, and thank you again to Gabe and Thaddeus. We really appreciate this.